Thank you for joining this lesson. We're going to look at vector 2, number 21 in this paper. The question says that triangle A or OAB is such that OA is A and OB is vector B. Point C divides OA in the ratio 1:3 and point D divides AB in the ratio 5:2. CB and OD intersect at E. The first thing we should do before we continue approaching the question is we sketch the triangle first of all. So if we say this is our triangle OAB, then we say that now there is a point C dividing OA in the ratio 1:3. It means then C is somewhere here. So that is 1:3. Then we have another point D dividing AB in the ratio 5:2. Therefore, we have, D can be here. So that 5 proportions, then 2 proportions. Then now we're being told that OD, which is this line, OD, that's one line, and CB, this is the line, intersect at point E. So this is point E. That is how the triangle should look like. Express the following vectors in terms of A and B. The following vectors are, first of all, OD. Remember, this is vector A and this is vector B. Vector B. OD. Vector OD is going to be given by OA, then plus AD. Vector OA is already vector A, plus vector AD is going to be 5/7. 5/7 because the total length is 7 proportions into vector AB. And now vector AB should be known that vector AB is going to be AO, then OB, which means vector negative A, then plus B, which means vector B minus A. So this means now we can come to this part and say that vector OD will be given by A plus 5/7 into B minus A, which is our vector AB now. So now this is going to be A plus 5/7B minus 5/7 vector A. And when we group the vectors together, A minus 5/7, we get 2/7. Therefore, this is going to finally be 2/7 vector A plus 5/7 vector B. So 5/7 vector B plus 2/7 vector A. That is the expression of the first vector. Then vector BC. Vector BC can be given by BO. Then we add OC. BO is the reverse of vector B, so negative B, plus OC. And OC is going to be 1/4 of vector A, which means we can rearrange this one to a quarter vector A, then minus vector B. The two vectors have now been expressed. Let us get to part B. Given that OE equals to KOD and CE equals to HCB, express OD in terms of, so we're going to express OD in 2 terms. First, in terms of K, which means we are going to follow the root which is having an OD, So vector, we are expressing OE. Express OD in 2 ways, such that we first of all accommodate vector OE. which means to express OD such that we accommodate OE, then it means we will start with the OE itself, which is equal to vector K times OD, and OD has been written up there. OD is 2 out of 7A plus 5 out of 7 vector B, which means this is a 2 out of 7 K vector A plus 5 out of 7 K vector B. That is one expression of OE. This must be OE, sorry. Then now OE again, but now following CE. Now following CE, which means OE, according to the diagram, OE following CE should be OC, vector OC, then we add CE, and now vector OC is a quarter of A, then we add CE, which is going to be H, vector BC, vector CB, that is, and vector CB is the reverse of BC, which means now it will be B minus a quarter vector A. The reverse of BC will give us CB. Therefore, we can have this one as a quarter vector A plus BH or HB minus a quarter H vector A. We can group the parts with vector A, so that we remain with a quarter, then minus a quarter H, and vector A is factored out, plus H vector B. So that is the second expression of OE. Finally, we are finding the values of H and K. Now that we have an expression of OE and another expression of OE, then we can equate the two vectors, the two components in each vector. In the first expression and the second expression, we equate the components of B, for example, so that you may say in the first expression, the coefficients of vector B are 5 out of 7K. 5 out of 7K. We equate these ones with the coefficient of B in the other one, which will be HB. So the coefficient is H. And we have this one as the first equation. Then the second equation, we equate the components of A such that 2 out of 7K is equated to the components of A, which is a quarter, plus a quarter H. These are minus, sorry, according to this second expression. So now after this, we can use a substitution method whereby from equation 1, this is equation 2. From equation 1, we know that H equals to 5 out of 7K. Therefore, we will have 2 out of 7K equals to a quarter minus a quarter. Then H, we use 5 out of 7K. 5 out of 7K. So that we may say now, this is 5 out of 28 negative. And when we bring it to this side, we add it. So we remain with a quarter here. But on this side, we shall add 5 out of 28 to 2 out of 7. So 2 out of 7 plus 5 out of 28. This gives me 13 out of 28K. So 13 out of 28K. To remain with K, then we need to multiply with 28 out of 13 on both sides. So a quarter times 28 out of 13. Quarter times 28 out of 13, which gives us 7 out of 13 as our value of k. This means that our h can now be obtained, and h is going to be 5 out of 7, the value of k, which is 7 out of 13. This is according to the first equation here. So h is equal to 5 out of 7 times 7 out of 3. And I think a 7 will simplify, and h is going to be 5 out of 13. That is going to be the last constant. Thank you for following. Subscribe and share.